You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by John Gertz. John Gertz is the president and CEO of Zorro Productions Incorporated, which he founded in 1977. He has been responsible for 4 Zorro motion pictures. He is an avid amateur astronomer, past president of the Berkeley Jewish Community Center Board, and various other non-profit boards. He earned his MA in psychophysiology from Haifa University, and his BA in Comparative Mythology and Religion at UCLA and Prescott College. Remember to subscribe to Event Horizon so you never miss an episode.
John Gertz, welcome to the program.
Well, thanks, John. It's a pleasure to be here.
Now, John, you usually work in film, but you have an interest in SETI and have been an advocate for it for a long time. And you have an interesting view in that you don't seem to think that we should look so much for distant radio signals, but maybe radio signals from relays, much closer, a galactic internet of sort, where these nodes transmit radio in between each other as how aliens communicate, as opposed to big beacons and things that were envisioned in the past, like Oconee and Morrison. Lay out the idea of a relay system.
Well, I try to look at the whole problem of SETI from ET's perspective. What would make a strategic sense for them if they intend actually to communicate or to learn about us? And it's my considered opinion that the old paradigm that they're going to transmit signals from their star system to our star system is broken. It would not be the way that ET would choose to communicate. I can tell you the reasons for that, but since your question is about why would they use probes, what I call probes, or you might think of as satellites or robotic AI machines that they've launched into our own solar system, is several-fold. First of all, a probe can actually conduct science in the absence of any form of communication between us. A probe, once entering our solar system, determined that we are in fact a biologically active planet. They could have determined that to 3.5 billion years ago. Then having determined that there's actual biology on planet Earth, they might have sent probes at a pace of, let's say, 100 million years, once every 100 million years, to check in on us. And after a while, after several billion years, they would have determined by the oxygen in our atmosphere that now we may be a multicellular planet, which then raises the stakes a bit, and they may have then decided to send probes to fly by, let's say, on the basis of every 10 million years or thereabouts. And eventually they may decide that there is an opportunity that the megafauna that they may have detected may actually evolve into a technological civilization. And at that point, maybe they would have planted a permanent probe to orbit the sun, to orbit the moon, to orbit anywhere within our solar system. Now in the meantime, that probe or series of probes can send actual data back to the home base, learning something about our planet. Once the probes have determined that we're actually a technological society, by for example, even before they would have measured the leakage of our electromagnetic signature after the advent of commercial radio, perhaps, or commercial television, even before that, they might have seen our cities being built, pyramids, agriculture, and so forth and so on. But having then now, once they are able to monitor our electromagnetic leakage, then they can actually learn something of our culture or our language, presumably not from radio waves in the 20s or 30s, but from television in the 50s and thereafter. They would have been able to learn quite a bit about us. They could have learned our language from Sesame Street. They could have learned our math from Khan Academy. They could have basically learned most of the rest from YouTube. And if and when they ever decide to communicate with us, it would be on the basis of actually having decoded us and actually have learned something about us. So they may actually respond to us in the Queen's very old English, or maybe in Chinese, or maybe in Urdu. It's hard. We're not committing them to any particular language. The probe also solves many, many other problems vis-a-vis the paradigm of transmitting from their home planet electromagnetic signals, be it radio or lasers. For one thing, the cost of the information that they're conveying to us, if they're actually planning to convey information, is much cheaper on a bit-by-bit basis. They can simply inscribe whatever they want to tell us on their version of a hard drive. And however you measure it, getting that hard drive physically to our solar system is a vastly cheaper enterprise than transmitting that same information from interstellar distances over deep time, because they would have had to have been transmitting that information, perhaps for several billion years. They would have no a priori knowledge in the absence of having sent probes of exactly when we had turned technological. They presumably would have known that Earth is only 4.55 billion years old. Fair enough, but they wouldn't necessarily know when we had turned technological. Maybe their models of might say, well, it takes 4.5 billion years plus or minus a billion years to go from life to technology. But they wouldn't have had an exact notion. So to transmit over deep time persistently would be a very expensive and time-consuming operation vis-a-vis sending probes. It's also much less dangerous to send probes. The galaxy may contain some very bad actors. We obviously have no idea at this point, but ET that might be trying to communicate with us might have a very good idea. When they transmit from their home star system, they, by definition, reveal their location. When they send probes, that probe may not be empowered and may not even know the address of the progenitor civilization. Probes completely solve for the L factor in the Drake equation. The problem with that the Drake equation set up with its factor L, as some listeners may know, may be that Drake postulated that two civilizations can only communicate if they exist at the same time in galactic history, that time as adjusted by the speed of light for information to go from one to the other. So if our civilization exists for only 10,000 years or 100,000 years, and the other civilization only exists for 100,000 years, those 200,000 years have to overlap within the 13.7 billion year lifespan or history of the universe. Chances are not great that they will. But once a probe is launched, it's launched. It's gone. And the fate of the progenitor civilization is no longer a factor. It need no longer persist.
That's an interesting point, that if you send out a radio signal, you are sending out a roadmap to your homeworld. But if you send out a probe, there's not really any way to know where that came from if you found it. You can't really say, it preserves no information of its origins. So it's
unless it wants to.
Unless it wants to.
Exactly. It depends on how it's being programmed.
Now, such a probe has a certain power that I particularly find fascinating. So we find von Neumann probe, right? That's been watching this planet perhaps repeatedly, different probes over many years, building a corpus of knowledge of the natural history of Earth. That would be a heck of a gift to give a civilization on contact and say, here is a record of the entire natural history of your planet. There's a picture of a dinosaur. Something like that, where they could actually also offer something of value to the civilization that they're contacting when they do make contact with that probe, right?
Well, that's a fantastic point. And I agree with you on that, but presumably they have much more that they can offer on contact as well. That's entirely up to them. But they presumably have a copy of Encyclopedia Galactica inscribed on their version of a hard drive. So they probably have brought all kinds of knowledge and information with them. But to feed back information about our own planet is honestly something I've never considered before, John, and I think it's a fantastic point.
I think it'd be a nice way to do a first contact is, here you go. And then also, here's physics. Not just part of physics or an incomplete understanding, but here's physics, the entirety of it. So you could do all sorts of things. Do you see, now projecting what an alien civilization might do, let's project it to us. Do you see us someday setting up this sort of a node type communication as we explore different star systems?
Better yet, Look, when you're using the word node, I'm assuming and agreeing and also postulate that the probe is connected to other probes. So the probe hypothesis has one deep problem embedded within it, that it is only a one-way system, at least simplistically. When the civilization sends a probe, it enters into the Earth's solar system, into our solar system somewhere. Maybe it's sitting on an asteroid, maybe it's in orbit around the sun. We don't know. But if and when it deigns to communicate with us and deigns to download to us the Encyclopedia Galactica, or whatever it's brought along with it for our benefit or understanding, how is it going to get information about us back to its progenitor civilization? And the way that I would postulate doing that is through a system of transmitter towers, if you will, or transmitting nodes. So essentially, information is entirely caroming or bouncing around the galaxy, and that information in the whole system actually is only growing as more civilizations contribute information to it. It's stored and saved redundantly in the system because there may be nodes around every star that each and every one of them is able to control, is to absorb information and retransmit it onwards, just like a cell phone tower.
Bad actors, you say, where there may be something lurking out there that isn't isn't very nice, and other civilizations might not really want to get its attention, so to speak, with a radio beacon. And maybe that's the reason. Maybe that's the solution to the Fermi paradox, is that there's just nobody's really speaking very loudly, and that they just quietly murmur with these. Essentially a cell phone network with these nodes, where it's a much more efficient way, but it's also much quieter. And you guarantee that even if you don't know if there's a bad actor, it's better to be stealthy and quiet just in case there is, right?
Right. And so what exactly do we know of ET's intentions and capabilities? The answer is absolutely nothing. Whether ET is similar to Spielberg's smiling characters from Close Encounters or ET, or more similar to Ridley Scott's Aliens, or something else altogether, we literally have no idea. And what about their capabilities? It could be said, well, what harm could they do us? I mean, astronomical distances are, after all, astronomical. And I would return to that our thought that ET cannot harm us from great distances, interstellar distances, may be utterly naive, is similar to the Hittites or something. Not being able to understand warfare at a distance further than wherever their arrows could shoot. They would have no conscientiousness or conception of missiles and bombers and artillery and on and on. So we don't know if ET could harm us from great distances, but certainly a reasonable solution to the so-called Fermi's paradox, which a term I don't refer to. I prefer David Brin's Great Silence. But one entirely viable solution to it is that ET knows something that we don't, and that is that the galaxy is filled with some very bad actors who can do some very real damage, and they keep their heads down. But with an intergalactic internet, or an interstellar internet that's composed of narrow beam lasers, the universe and the galaxy could be just filled with signals going back and forth all over the place. And we would be oblivious to it simply by virtue of the fact we're not within those very narrow beams, and very intentionally not within those narrow beams. So those beams may go from star to star, from Sol, our star, to Alpha Centauri or other nearby stars. And Earth simply, and very intentionally on the part of the probes, simply doesn't go through any of those laser beams. And what to us looks like the great silence is, in fact, a great cacophony of information going backwards and forwards all over the galaxy.
Now, you say preferring David Brin's view of the great silence versus, which, by the way, there's my train going by, the great silence versus the Fermi paradox. And some people have said, it's not a paradox, and things like that. What's your view? Extrapolate your view on that. Why the great silence is a better term for it?
Well, first of all, Fermi himself never seemed to posit this problem. He was interested, at the time, it seemed, about alien spacecraft. The question for him seemed to be, if UFOs, which were then just coming into some sort of recognition, common recognition, if UFOs existed, how come we don't see them all? And he seemed to be throwing aspersions on the notion of whether or not space travel from interstellar travel is even possible. Something I also think is probably impossible by manned ships. So it's a mistake, I think, to ascribe to Fermi a view he never actually held, and it isn't a paradox. If you define the word paradox or look it up in the dictionary, it simply doesn't fit the definition of a paradox. So for those two reasons, I prefer David Brin's Great Silence to name Fermi's paradox, which is not a paradox, after a person who never made the argument.
True. Really, as near as I can tell, all he did was ask a question after, at a lunch at Los Alamos.
And even that's apocryphal. We don't really know for sure the date of it, the attendees, or what. It's all very vaguely lost in history.
Vaguely lost, but what's not lost is John von Neumann's ideas about self-replicating probes and how you could populate the entire galaxy within just a few million years at sublight speeds, not breaking the laws of physics with these types of probes. And, many of others have revised the idea, Bracewell probes, Benford probes, things like that these might actually be a feasible way to explore the galaxy, with the added benefit that with robots, you don't have to leave your star system. Well, you don't have to.
Well, I'm unpersuaded by von Neumann's argument, not on theoretical grounds. I mean, theoretically, it's an interesting construct. On practical grounds, I don't see it happening. And this leads into a very important point, however, so let me make it. The problem with von Neumann probes is that although technically, yes, it's real, you could imagine such a thing. When you get down to it, how is it going to happen in practice? Is a von Neumann probe going to land on an asteroid? And then how is it going to manufacture from that asteroid all of the parts? There's on YouTube a wonderful animation on all the inputs that are necessary for creating a very humble and simple number 2 pencil. You need a whole mining operation for the graphite. You need forestry operation to chop down the trees that are necessary for the pencils. But wait a second, you don't do that except with a chainsaw. But a chainsaw has 1,000 different components and inputs into a chainsaw. And then you need the oil and gas to run the chainsaw. And so now you've got a drilling operation that you're going to need. And now what about the metal band that ties the eraser together and the plantations for the rubber? Well, you take that and you multiply that sort of complexity apply that to a vastly more complicated von Neumann replicator. How are they going to manufacture the chips and make a chip fabrication factory for a von Neumann robot? It just staggers my brain. But now, why that's so important is that if, in fact, we find alien probes within our own solar system, they will eventually communicate with us. And they will not destroy us, although Lord knows if they've seen the nightly news, if they're tuned into our nightly news, they may think we richly deserve it. And they were a pretty wretched place. But they ultimately, and this is the bottom line, we have a lot of trading power with them. We have a lot of leverage with them because they need us to manufacture the probes and to help maintain our region of the galaxy. And so I can see them instructing us on how to manufacture and deploy probes and launch them to all the nearby star systems and beyond, and help maintain the galactic internet. That's our trading power, and for that we should ask them for great knowledge and wisdom and so forth.
Once you do that, and you've got some kind of contact through whatever means, how do you understand it? How do you figure out exactly what an alien civilization, number one, what their signal looks like? But say you get it. Say you get a narrowband signal, and it's obviously technological, something like that. But you don't have any other commonality with it other than being able to use radio, even with a relay. So how do you communicate with it?
Okay, it's a deep problem when it comes to signaling back and forth across interstellar distances and it's one of the reasons why ET would not opt to send us signals, because They may speak to one another in bee-like waggle dances or cuttlefish-like colors or something like that. They have no way of knowing, in the absence of who we are, that they should be sending words, or much less what words and what kind of language and so forth. There are deep, deep problems of communicating with ET. There's the problem of the modality of communication. But we can't even understand dolphins or any other sentient beings on our own planet. We're not able yet to communicate with them. How are we going to communicate with ET? There's the problem not just of their communication modalities, but their sensory modalities. I feel like I've got some sort of mutual understanding with my dog. But when I take my dog for a walk and the dog stops to smell the bushes, I have no idea what world of smells my dog is entering into. And I'm completely insensible to this world of and the glories of various types of splotches of dog urine, which leads into not only am I insensitive to it, I don't care about it. My dog and I have different interests. She's interested in dog urine and I'm interested in SETI. I can't talk to her about SETI and she has no way of communicating with me all the glories and beauties of different levels and types and bouquets of dog urine. So there's the gap of the intellectual gap that will no doubt obtain between ourselves and ET. If we were to come in contact with Homo habilis, it would be absolutely pointless for us to try to talk to them about Shakespeare or Einstein. And on the other hand, we don't have a lot of use for their scrapers or the rest of their stone tools. So what are we going to talk about? So there's huge problems. And the only solution that I see about it is that provided by probes. These robotic AI-driven probes are studying us, decoding us, learning about us, and when they can communicate back to us, it will be from the vantage point of having learned a great deal about us, which may be very, very different than what they're about. So if they communicate with us in English, it doesn't mean that, that they really have a deep coherence with us. The entity that's speaking English may be representing entities that are vastly and wildly different from us. And I believe that one of the reasons why we don't hear from these probes, which are here right now in our own solar system, if ET only exists, provided only that ET exists, then they're here. They're already in our solar system. They've had plenty of time to get here, and they're here. But it doesn't mean that the local probe has either the ability or the authority to communicate with us without feedback from their home system. In other words, they may need to transmit a great deal of data about us back to the home system for deeper analysis than they're capable of on board, and or they may need and seek authority from the home planetary system on how to proceed. Either to open communication with us, study us for a longer period of time, or because we're a wretched civilization to destroy us forthwith. Anyway, so it may be in that respect, if their home base is 1,000 light years away, it could be another couple of millennium before we hear anything from these probes.
That may be a solution to the Great Silence in and of itself, is the idea that any communication is futile, that there's just no point. So don't. Instead, just send out your probes and watch and do whatever science you're interested in and leave it at that.
Well, there is communication. If you forgive me, there is communication that is vital. There's essentially one piece of information that needs to be transmitted, and that is the law. And it may be that probes aren't here to give us great instructions on the cure for cancer or how to make world peace or whatever, but they're here to just read us the Riot Act. That in effect, there is a galactic law, and that law could be comprised of just two words: don't come, stay still. You get the point that you move, you die, something like that, something along those lines. I mean, very simple law. It's not do unto others or anything like that, but it's as simple. The galactic rule is you stay on your own home planet, and you don't try to go out and colonize others. The other thing, as I've already said, is that they desperately need us to help in the creation and maintenance of the intergalactic communication or the interstellar communication network. And why do you have an interstellar communication network in the first place, if not to transmit information among civilizations? And I would imagine that this system could, in some respect, act as a dating service. It could shunt our information towards civilizations with whom we have some commonality. So if there are, as Frank Drake speculated, there were 10,000 extant civilizations in our galaxy, well, maybe 3 or 4 or 5 of them have enough in common with us that it's worth getting to know them. Well, the interstellar system of communication could put us in more or less direct contact with them without ever giving away their coordinates or ours.
That's a really interesting thought, that it works as a kind of commonality booster, where it just says, you can't really, you're never going to understand that group of aliens over there, but we got some that you might, and does it that way. But I also wonder if the probe itself might be a commonality, because it's going to have to work on scientific principles and stay within the laws of physics. So it's going to probably resemble electronics, and it may be far more advanced, but maybe that's the point, is that you're supposed to find the probe so you learn how to make the material you need to join that civilization or galactic federation of sorts. Because one thing that I think a lot of people don't realize is that this galaxy has been able to support habitable worlds far longer than Earth has been here, the solar system, the 4.6 billion years, but it actually is a few billion years further than that it could have done it. So there could be unbelievably advanced alien civilizations out there that we just don't know what we're looking at when we look to the stars.
Well, there are just 2 things that we know for an absolute certainty about ET, and one is that, as we've already discussed, ET is not obvious. That's the first fact we know about ET. ET is not obvious. Why it is that we can't look up in the sky and see evidence of ET as plainly as we see the full moon is a deep mystery, because they've had billions of years to get here and make themselves known in that respect. That's the great silence. The second thing that we know about ET for an absolute certainty, absolutely near certainty, is that ET is vastly more advanced than us. Any ET that we encounter will be not just thousands of years more advanced than us, but at least millions of years more advanced, and more likely billions of years more advanced than us. Because the first civilization, ET civilization in our galaxy, may have been born as early as 8 or 9 billion years ago. That's one hell of a head start that they've had on us. You have to assume that they, the universe is 13.7 billion years old. You have to assume that life couldn't have gotten going for the first several billion years, but or probably only just the first billion years, maybe the first 1.5 billion years. Thereafter, you can have life and add 4 or 5 billion years to that, and you come to something like 9 billion years ago, you could have had your first civilizations. That's a long time and a great deal of advancement. But when I say that they're more advanced than us, I just mean technologically, as defined by the ability to send or receive radio or optical signals across interstellar space. We know we're only in our first 100 years of being able to receive or send signals. The chances that they are also in their first 100 years are statistic out of the 9 billion years is statistically negligible.
That also isn't said enough. We've only had radio telescopes for a very short time, less than 100 years, and that's an awfully short amount of time to look at star systems and practice SETI. And it may actually simply be that if you're going to detect an alien signal of any type, whether it's you're eavesdropping on a probe or you're hearing a civilization's I Love Lucy, whatever, maybe that process takes thousands of years before you finally see it, and that we just haven't looked long enough. What are your views on that?
Well, yeah, it's true that it may be that we haven't looked long enough and hard enough, but I don't believe that ET is actually sending us signals from interstellarly for all the reasons I've already said. But even within our own solar system, There simply hasn't been enough time for ET to have studied us and learned enough about us to decode us properly or to send back and ask for permission to make contact with us. So I think we're just going to have to be a little bit more patient about that. And when I say a little bit more patient, it may be that we have to wait hundreds, thousands of years before we get an answer to this.
Looking for such a probe in the solar system. So how do we do SETI in that regard? Close SETI, looking for some kind of a probe that was left here. Say for example, say it was even easier than colonizing the whole galaxy, and it was just at some point the sun passed by another star close enough, within a light year or two, and deposited a probe here. How do we look for that?
It's a very good question. I've got an answer for it of sorts, but that is, there are certain places in our solar system that are more likely to find a probe than not to find a probe. But truthfully, the probe could be in any one of the 41,000 plus square degrees of the sky. Could be anywhere. But if I had to bet, I think the probe would be in a close orbit around the sun, probably within the orbit of Mercury, for two reasons. Number one, they could obviously collect energy there from the sun, but secondarily, because that's a good location for sister probes around other stars to find one another. All they have to do is point at the other star, and the laser beam would be wide enough to encompass a probe in a near solar orbit. So that's a place I would look. But the question is, how are you looking for it? They're very small. They could be, I don't think they would be any bigger than a school bus and possibly no bigger than a basketball or something. The question is, how do you look for them? And basically, you're waiting for them to signal to you. You could try to intersect one of their signals to another node. So you could, when the Earth gets in between a spot where you think a probe might be and another star system or nearby star system, then you can start looking in that spot and see if you can intercept that message. But the probe presumably is smart enough not to, if it's trying to hide from us and not yet ready to reveal its presence, I can't imagine why it would be trying to communicate with another node at the exact same time when our planet is occulting that signal. So I think that although there are preferred places, maybe sitting on the surface of an asteroid is another possible place. There are preferred places. Nonetheless, I think that we're stuck, that essentially we're going to have to wait for the probe to open up a channel of communication to us. And when it does so, I mean, it's great that we have the most powerful radio and optical telescopes in the world at our service, but they're not necessary. Essentially, a probe with even modest power is going to be an object, if it seeks to communicate, that will be quite visible to us. If it's a radio signal, there are thousands of radio antenna around the world, mid-sized radio antenna around the world for aircraft and other purposes, satellite communications, other communications. They'll pick it up. It could be that it's going to be brighter yet and take over channel 12 or on your television or 88.5 on your radio. It could be that simple and that loud. If it's a laser, it may be the brightest object in the sky, and certainly any amateur astronomer would instantly notice a star that isn't supposed to be there. And a bright one is that, and much brighter than any other star, brighter than Venus, presumably, probably even brighter yet than that. So it would be noticeable almost instantaneously. Any telescope then looking at it would see that it's monochromatic light, it's not natural light. So a laser would be a slam dunk and an easy thing to find. So we may be just stuck and waiting for them to communicate with us, and not much we can do about it. Maybe by serendipity, if in the near future, if a private company is mining an asteroid and finds a probe on the asteroid, and there may be a lot of space junk, alien space junk in our solar system that we could find by serendipity. By that, I mean to say maybe there are probes that of millions of years ago that have gone dead and silent. And it may be that there are 1,000 dead probes for every one that's currently active and able to communicate.
One of those preferred places, if you really want to be stealthy until you whatever civilization you're studying is at an actual technological level to even communicate with, you could do it on the far side of the moon and we'd never know it was there because, yeah, we send probes, humans and probes and things like that, but they're not looking at all frequencies. They're not, a huge multi-million channel radio telescope. So there could be a probe sitting on the far side of the moon and we wouldn't know it. Or as you say, if it's in solar orbit and it only transmits and does a data dump every 50,000 years, then you're not going to see that because otherwise it's a needle in the haystack. So it's hard. It would be hard it would not be obvious, not necessarily be obvious that there is a probe here.
Well, there is a hope here actually in finding it. When I said that it's probably the size of a baseball or a basketball or something, I have absolutely no idea. But I'm talking about the payload. The payload may be quite small, their hard drive or whatever. But what could be quite large is their transmitter, because they're constrained by the same laws of physics as we are. And if a transmitter is going to transmit to the next probe around Alpha Centauri or wherever it is, the antenna is going to either have to be quite large or the power source going to be pretty large. So we may have some hope of finding a physical object that is very large by virtue of it being the transmitter and antenna. And if that's on the far side of the moon, we should be able to find that in our archives of photographic evidence of the moon, which I believe is pretty granular for most of the moon now, down to certain square feet or square yards at the most.
Yeah, it's getting much better with India and China actively basically mapping the moon at a greater resolution than what was possible before. And I mean, let's face it, it looks like we're going to go there again. Human feet on the moon. It's the first time since 1975, something like that, 74 or 72 actually. Now, when within all of this, within SETI, we tend to define things with things like the Drake equation. And again, also the Fermi paradox, so-called great silence. And we use those to sort of define the question. What are your thoughts on the Drake equation? And is it even an equation, really?
Well, let me preface this by saying that I was quite close to Frank Drake, a lovely, lovely human being, very humble, a lot of wisdom with him. I always enjoyed listening to him. Just a genuinely decent human being. That having been said, the equation is truly ready for the ash heap of history. It's not only useless, it's counterproductive. It leads us into wrong ways of thinking. Almost every one of its factors every one of its 7 factors, which then multiply out to the so-called N, or the number of civilizations in the galaxy that we're able to communicate with. Every one of the factors is so badly wanting, out of step with reality, that it should be just completely scrapped and dumped. I don't know. Take one at random, if you will. Well, let's start almost at the beginning. The rate of star creation is, I don't even know what it's doing in there. It's got the rate at which stars are being created in the universe tells us nothing about how many civilizations eventually arise. The rate of star formation is now was 10 times higher in the past than it is currently. What the current rate of star formation is irrelevant. What is relevant is the number of stars that could possibly contain a civilization, and that number is hardly constrained at all. The whole gamut of stars, except for the largest that are going to supernova, are completely fair game for the determination of whether or not they house a civilization. So the next factor is the frequency in which stars form planets. Well, that's known already. It's for all intents and purposes, it's 1. Every star system has planets, and not just one planet, but whole systems of planets. So 1 times anything else only equals 1. So any factor that is unity or 1 can come out of the equation. The next factor is the number of Earth-like planets in a system. But wait a second, that presumes that only rocky planets within the so-called habitable system are habitable. No, that the habitable system where water can exist on the surface of the planet, that distance from this system is completely out of step with our current thinking. Life may exist in the clouds of Venus. There's been some indication of the discovery of phosphine, which only, as far as we know, is a byproduct of biological systems, has been found in the clouds of Venus. Maybe there's life floating around in the clouds of Venus. Mars, we all know about. But further out, we've got the moon of Europa, which is covered in ice, and the ice in turn covers an ocean that has many times the amount of water as all the oceans on Earth put together. Going further out to Saturn, you have Enceladus, which is everybody's current favorite for the possibility of containing life. I mean, Enceladus has all of the ingredients for life. It's got carbon, hydrogen, phosphorus, sulfur, nitrogen, oxygen. Of course, it's got water aplenty because it too is covered by ice, and which covers an ocean. But below the ocean is apparently hydrothermal vents, just like were thought to be the source of life on our planet. In fact, trace amounts of methane, which could have also been observed in the geysers that are presumably shot out of Enceladus from these hydrothermal vents. So that's out already to Saturn. And now New Horizons discovered that Pluto also probably has an ocean that's covered up by the surface ice. So if the habitable zone goes from the clouds of Venus to the ocean of Pluto and maybe even further, what good is this entire notion of the habitable zone anyway? And in fact, this is not just a theory. I mean, this is NASA and many other space agencies are betting their budgets on the idea that the habitable zone is much broader than just the Earth and a little in and a little out from the Earth, because we're sending spacecraft to Saturn and Jupiter and so forth, looking for the signs of life.
I've always found that to be really, really unusually interesting as far as discoveries within my lifetime, because back in the 1980s, as an amateur astronomer and teenager, I was like, there was only Earth, and maybe there might be something at Mars. We had this labeled release experiment that came back positive and stuff like that. But now the entire Kuiper Belt could be full of objects that have liquid water oceans because of radioactive decay in their cores. So there are habitable places in the solar system we don't even know exist yet.
Yeah, and not only, and I think we need to take even the word place as and look at it more broadly, because if you think of every hydrothermal vent and every pond and every cloud as a potential harbinger for the creation of life, then there could be billions or trillions of possible habitats for life in our solar system. So if we come up with, and if in our discoveries we do discover a sui generis form of life within our own solar system, in other words, a living or fossilized life form anywhere in our solar system that doesn't share our origin, in other words, we by panspermia did not arrive on Earth, or vice versa, that our biology has not infected that planet, but it's truly an independent genesis of life. And if we found that second origin of life within our own solar system, then it can only mean that life must be ubiquitous throughout the solar system. And so if the frequency of life throughout the solar system is again 1 or near 1, it can come right out of the Drake equation. It doesn't mean anything, because 1 times everything is just everything all over again. So you can march right through the Drake equation and rip it apart in 3 different ways, or many different ways, and come to the conclusion that it's basically worthless. And no solution to the Drake equation that we can pencil in any way, shape, or form is definitive. The solutions have been offered that go from 1, ourselves, n equals 1, us, to n equals 10 to the power of 8, and everything in between. So an equation that yields no definitive answer, but only asks the question, means basically it's crazy making, and let's just get back to doing SETI and searching for the answer, because that's the only way we're going to find it, is by searching.
You got to look if you're going to find anything, and if you don't look, you don't find anything at all. Now, A lot of people will make the case that we're already seeing evidence, of which I disagree with that somewhat strongly, but they say there's evidence that there's a civilization here in the form of the UFO phenomenon. What are your thoughts on that?
Well, I don't know anything more about UAPs than I do from the general media. I come to SETI from the perspective of astronomy and as a businessman, and try to ask what is ET's best way to communicate with us. And I came to the conclusion, quite independently of the UAP people and subject of UFOs. I've never seen a UFO. I've certainly never been beamed up by one. And come to a kind of similar solution that ET's best way of making contact with us is to come here physically. However, I'm very unpersuaded by the evidence that I've seen to date on UAPs. All of us carry around first grade cameras in our pockets, and yet I haven't seen any first grade pictures. If 40 strangers to each other all took out their cameras or their iPhones in an airplane and filmed the same UAP, that I would find impressive. But so far I haven't seen that evidence. I don't have an explanation for why there are no sonic booms. The very immense accelerations that are reputedly attributed to UAPs are only accompanied by sonic booms. So where are the sonic booms? I presume that ET is not able to change the law of physics, and physics demands that when the air is pushed around at that great speed, it creates the shock waves. I haven't seen the multi-sensory evidence for UAPs. I've heard that there may be some radar corroboration that would be interesting. I haven't personally seen it in the newspapers. So at this point, I'm dubious. One thing I think is certain, though, that if UAPs are in our atmosphere and are alien, that they are robotic. The very accelerations that have been attested to so many times, incapable from human machines, would presumably create life-destroying G-forces on any little green men who would be in those machines. Again, they can't escape the laws of physics any more than we can.
Yeah, and also to add something to that is the fact that if you move something through Earth's atmosphere that rapidly, it's going to look like a giant meteorite. It's going to be so subject to friction.
Yeah.
And yet we don't really see that with the reports. At the same time, I'm open. If evidence were to surface that met that bar, and that's really, we have to remember we're talking about the bar of science, then okay, there we go, let's study it. But I just have not seen enough to push me over the edge.
Yeah, I agree with you entirely. Let's continue to study the phenomenon, certainly take measurements, certainly everybody keep their cell phones handy to photograph for any UAPs and collect evidence and so on. I absolutely don't believe in any governmental conspiracy. That to me is just crazy thinking. Because look, such conspiracy would have to go through probably about 10 presidential administrations, that it would have to be international in scope because presumably UAPs are not just an American phenomenon. Can you even imagine Donald Trump, whether you vote for him or against him, do you believe that he would have kept it secret from the public? Can you imagine all the thousands of people throughout the 2 or 3 generations of UAP secret holders who would know this and not one of them ever reveal it, even on their deathbed or in a leaked package to the New York Times? No, there's no conspiracy out there. There's simply just a lack of evidence.
There is certainly conspiracy within the U.S. government to spend money unwisely. That's about all we ever find there. But who knows? These situations can change on a dime, and we all learn something new. Now, there has been within the history of SETI a number of interesting signals, enigmatic ones, but most well known is the WOW signal. And one of the hallmarks of the WOW signal was that it was very strong, 30 sigma detection at the Big Ear telescope. And it was where SETI astronomers sometimes say, well, we need a frequency to look at, so let's look at the hydrogen line where neutral hydrogen emits radiation. And lo and behold, we see it. We see the strong signal. And it never repeats. Nothing we can do with it other than say, that was interesting. But do you think that a signal like that was probably perhaps more likely to be close than distant.
Yes. Well, let me make 2 points on that. One is that there have been very few follow-up studies of the WOW coordinates. There have been far fewer than people seem to imagine, that we've gone back and back and back and never seen anything again. Actually, there hasn't been that much. People have gone back and looked at it, but for 10 minutes here or an hour there, not persistently. But what no one has done is simply regarded as an object in our own solar system that was in transit at that point. So I would want to ask the question immediately, what else was in that field of view at that particular time? Was there an asteroid in that field of view? And if so, where's that asteroid now? That's where you want to look, not in the coordinates of the WOW system itself, but in the coordinates of wherever the asteroid might be today. But it also tells me 2 things about the standard paradigm of SETI, which is observing stars. The typical paradigm is you observe a star for 10 minutes and then you move on to the next star and then move on to the next star and so forth. One of the big problems with that is follow-up. If analysis is done in real time, which is rare, then you've got to have another telescope on call to immediately, confirm the observation. But much, much, much better would be to have another telescope that is in more or less the same longitude, but a different latitude, to be observing in tandem. No telescope should be looking at stars individually. They should be doing it at least in pairs, so that the second telescope can always confirm the first telescope. Can you imagine if Arecibo at the same time as the Big Ear was looking at the same WOW coordinates and saw the same thing? Then bingo, we'd all be popping the champagne and we'd have ourselves a confirmed detection. So to me, the idea of using just one telescope at a time is absolute folly. Now, however, most SETI is done offline, that is after the fact, and this is what happened at Ohio. It was days later or whatever that somebody looked at the printout. Well, immediately what you should be doing is assuming a signal is in the foreground and not the background. You can observe in the background, but you should now not just ask yourself, as I did, is whether there was an asteroid in the field of view, but assume now that it was just a free orbiting UAP or probe. What you need to do is then slew the telescope in a spiral around the spot of the original observation and just keep spiraling outwards, because you don't know what the orbital characteristics of the probe were, so you don't know in which direction it would be going. So the only way to determine it is to make a spiral around it and go as far out as possible. So that's my beef, if you will, with the WOW signal. Nobody confirmed it. Nobody was there with the second telescope, and nobody asked the question, what else was in that field of view at that time? And nobody slewed the telescope in a spiral. So a lost opportunity. Let's move on.
Yeah, unfortunately, that telescope wasn't even capable of it. It was pretty well fixed, yeah.
No, it wasn't. That telescope would not have been capable of it, but another telescope, the second telescope, might have been able to. Yeah.
Now, with today's equipment, let's take the Allen telescope array. Could you do it with that? I mean, can you self-confirm it by separating out 2 of the dishes and making separate observations with separate receivers and do it that way? Or do we not quite have that capability with that instrument?
It's certainly better than nothing. Okay. Yes, you can do that with the Allen telescope array. You can form separate beams. However, it doesn't get away from the problem of somebody's microwave oven, because the telescope dishes are near to each other. They're only tens of meters, a few tens of meters apart from each other, or even less. So it doesn't get away from the problem of a very localized RFI or radio frequency interference that's affecting both dishes. It doesn't get away from the problem of a localized hoax. So it helps. It's better with the Allen telescope array, where you can split it up into several beams, but it's not an ironclad solution to the problem.
That's one of the things that always worried me about the WOW signal, is that if you got some college student that's the Ohio State University, and they're like, I'm going to go and mess with the radio astronomers and just put a little signal into that feed horn, and not the second one, and pull something like that, because again, that would explain the strong signal. But it is interesting. At the same time, though, do you think that with other signals, and there's only been a few that were really interesting, but with other signals, do you think maybe that we might have too stringent of criteria? Because sometimes, and I can't remember the name of the signal, but it actually repeated 3 times. And it was, very, very weak. And then it was just basically abandoned and said, well, this is so weak, it's nothing. Do you think that that's prudent, and to sort of not follow up on signals like that?
Yeah, well, I don't know which exact signal you're referring to, but there are transients, and our SETI analysis is only as good as as the algorithms that we run. It could be that the signal looks different than our algorithms pick up. Again, it really points to the necessity of doing SETI on multiple telescopes at the same time, looking at the same target. That's the best check on the system, because if you've got a weak signal, as you've characterized, one that was marginal, maybe it's something, maybe it's not something. If another telescope picked it up, it would magnify the significance of the observation many-fold.
Now, John, there is a sort of elephant in the room in that, what if we do detect a signal and we do find a proof positive of the existence of an alien civilization out there somewhere? What do we do? What do we do after detection? What is the protocols that we should put into place once we find some kind of signal, whether near or far?
In my view, the detection of a signal is SETI. It is science. But from the exact moment of detection and thereafter, it leaves the field of science and enters the field of public policy. SETI scientists at that point need to stand back, get out of the way, and just take a secondary advisory role to the main action, which has to be diplomatic. And so what I have recently called for is the creation of an international treaty governing all aspects of post-detection. And I regard this as extraordinarily urgent. And why is it so urgent? Because this is we're in a very new age as of right now, and as that anything that is heretofore existed for a lot of different reasons. One, because money is now flowed into SETI, there is more SETI being conducted today than used to be conducted in a whole year. So a single day of SETI is more productive today than a whole year's worth of SETI was just a few years ago. That's because of the money that is now with Breakthrough Listen in the SETI Institute, and very particularly because the Chinese are also in the field and also using their telescope, their radio telescope, which is the largest single dish radio telescope in the world, the FAST telescope, for the purposes of SETI. Because the Chinese are now in the field, that opens up a whole another host of issues. Will they immediately take their detection of SETI and share it with the world, just as our SETI scientists are committed to doing? I don't think so. My own personal bet is they'll stamp it top secret, and that'll be the end of the subject for as far as we understand it in the West. It's also because our leakage, our I Love Lucy signal, that's our television broadcasts of the 1950s and the radio signals before that, are expanding through space at the distance of 1 light year per year. More and more stars are coming within that envelope of our unintentional leakage, and therefore we might be hearing signals from stars that are close into us. And because the SETI today that we're doing is so much more powerful than the SETI we were doing in the past, the algorithms are more powerful, the telescopes are sometimes bigger and better, and particularly because of Moore's law, the back end has expanded, exponentially, or the power of the back end. So there are all these drivers, plus the fact that if I'm correct, and that the first detection we make is of a local probe and not of a distant star system, that local probe every year is having more and more time to watch I Love Lucy in reruns and tap into our internet and learn our math from Khan Academy and learn our English from Sesame Street. And the likelihood keeps growing every year that probe will have absorbed enough, decoded enough, that it feels confident enough, if that's the term you can attribute to an artificial intelligence, to be able to then open up that channel of communication. So it's urgent that we get our act together. Right now, there is no understood protocol for post-detection. I'll give you a very, very simple situation, and one that's extraordinarily fraught. Let us say, for the sake of example, that I've been wrong in suggesting that we'll hear from probes, and we in fact hear from a star system that may be, let's say, 1,000 light years away. And it's a list of prime numbers or something that they've signaled to us. What do? Well, I don't know. Do we answer? Do we send back our list of prime numbers and signal to them, in effect? We interpret their download of prime numbers as their invitation to open a conversation. We upload our list of prime numbers to answer them and say, yeah, we're open to it also. Or at least that's what the implication is. Should we send a signal or should we not send a signal? It's, the obvious answer may be yes. The non-obvious answer maybe no, because maybe it's too risky. Maybe this is just a bad actor civilization that is effectively using echolocation to locate its prey. In other words, if we answer back, we tell them exactly where we are, and the next thing we know, we've invited our own destruction. So I'm not saying we shouldn't answer that. What I am saying is that who gets to decide this yes or no, possibly life-changing act? Well, obviously, it should be democratically decided. The best we can do at this point is to work through the United Nations and make a decision among nations. But how is that decision made? Is it made by a vote of 3/4 of the countries of the General Assembly? Is it by the 2/3 of the vote of the Security Council? How? What? I don't know. I don't have the answer to that. But as we think about it, we must think about the answer to that today and not in the future. Why? Because we may need to react in moments and have our answer to these questions ready on the instant. Why? Because if that civilization of 100 light years away or 1,000 light years away is like us, where we listen to each individual star for a 10-minute period and then we move on to the next one, maybe they're signaling to us for 10 minutes and waiting for a response. So if they're 1,000 light years away, they point their antenna towards us for 2,000 years later. In other words, they'll allow for this speed of light going to and fro. Maybe they only wait for 10 minutes or 10 hours or 10 days or 10, who knows? We don't know. We may miss our opportunity if we don't have an instant response. So these issues and many, many more like them should be debated now. So in my judgment, what we need to do is convene a committee of experts to immediately adjudicate and to advise on these types of issues. Experts, not just astronomers, perish the thought, but experts in national security, law, cryptology, behavioral psychology, game theory, economics, linguistics, evolutionary biology, diplomacy, emergency planning, religion, ethics, epidemiology, rockets and space science, mathematics, you name it. Form a standing committee of experts to spend not even necessarily years, but decades studying these topics, deciding on how to construct a message, what we're going to be saying in return, how we're going to treat a probe, an intelligent probe, if we come into possession of it. Should it be treated like an ambassador and given all the honors, even though it's obviously of artificial derivation? I should think yes. But all of this, after we contemplate it and advise on it, should be encapsulated into an international treaty that's binding. There should be, in that treaty, there should be a right of transparency, so that we get the Chinese data and they get our data on a real-time basis. so that it diminishes, it can never probably eliminate the idea that one country is going to hog all of the information to itself. It should be absolutely precluded that we should make any communication that is not authorized by the United Nations and decided upon by everybody. Otherwise, you're going to have Kim Jong-un sending his parochial message, the Scientologists sending theirs, and it's going to be a big mess. Should the coordinates, if it is a star, should the coordinates be released to the public? The information should be, I presume, if it's benign, I can imagine circumstances where the information should be vetted. If ET says that it's going to give us the cure for cancer, but it demands in return that we download its version of DNA to replicate in our laboratories and create their beings on our planet, maybe we ought to have a conversation about that first. Maybe we shouldn't disseminate that information, and maybe should be vetted and redacted in terms. So all of the issues here are complicated, but requires a lot of people thinking about it in a deep fashion for a long period of time to begin to congeal a coherent set of public policies.
That's interesting. And I would imagine the first step is some kind of international agreement, which right now may not be very easily done, but some kind of international agreement not to practice METI. Don't send a message until we've all had time to deliberate in the UN as to what we would do once we detected a signal, if we do anything. And you're right, there is no framework for this yet. And it would seem to me that should be something some UN committee should be contemplating already.
Well, it is not. There is a standing committee on space. COPUOS is called, the Committee on the Peaceful Use of Outer Space. But it meets infrequently, and it works only by consensus, and the expertise there is not multidisciplinary enough. So it isn't necessarily the right organization for this. I would suggest that a different organization be made, or agency within the UN that's fully funded, that would be much larger and more comprehensive than the current committee. But then I would certainly agree with you that METI should be absolutely prohibited. We haven't really spoken about METI, but I want to say that I personally regard METI as not only dangerous and arrogant, delusional, unethical, unscientific. It's cultic. I don't have a lot of good things to say about METI, if you pardon my expressions here.
Well, my problem with METI is that anybody could do it, and you do not speak for the entire planet, because whenever you're dealing with something alien, an alien civilization, you're doing it as an entire planet. You're not doing it as the United States or some guy with a radio transmitter. I'm just going to point it up there. The thing is that the power is the question. And that was always my issue with the Arecibo signal, because it did have power. And it didn't repeat. We only sent it once, and we sent it to an area that's not likely to have aliens, star cluster. But still, don't do those things for fun. Be prudent about it. And that's what one of the things I hope we can establish with a committee, as you laid out, that just don't do METI until we've all had plenty of time to talk.
Right. I mean, with METI, it's unauthorized diplomacy. It's public policy taken upon itself. It's not scientific whatsoever. It's not trying to learn anything about the universe. It's trying to manipulate the universe. In a way, it's tweaking the experiment. And what is the message that they're going to say? In whose name are they saying it? The people, the proponents of METI will say, well, we won't be our message. It'll be the internet. We'll just give them everything that we've got. Well, as a businessman, I particularly object to that. I mean, what is the currency of the interstellar economy? It can only be information. I can't imagine what else we've got to trade with ET. If we give them all of our information, our internet, for free, they're going to think we're the most foolish species that ever existed in the galaxy and laugh up their sleeves at us and not give us nothing in return. No, if we might give them one of the Beethoven symphonies and a painting by Monet and a little gamelan music or something, and trade with them as a loss leader. We'll give them this and then trade them for the rest. So even that sort of seemingly benign notion that we're just going to give them everything, so don't worry about it. I particularly object to that there's no methodology whatsoever. These people that claim they're scientists have no method for return signals. So if they propose to send a signal to a star that's 50 light years away, have they reserved a telescope for the return signal 100 years hence? Of course not. They haven't rented a telescope 100 years from now. And if they had, have they rented it for 10 minutes or 10 centuries? Because we don't know how long ET would take to analyze our METI message and decide how to respond to it. Moreover, one telescope isn't enough. They're going to need multiple telescopes spaced around the world, because as the world turns, the ET's transmitter will go below our horizon. And so you've got to have multiple dedicated receivers. But their response is basically religious, that the ET must, first of all, be only good and want to do nothing but send us beneficence, when in fact ET could be a very terrible actor. Two, that ET is omniscient, that they know that we're here, even though our electromagnetic leakage or footprint is extremely weak. And finally, that ET is omnipotent, that even though they make absolutely no provision for the receipt of a return message, that somehow ET is going to know we're here and know how to communicate with us. So this belief that ET is omniscient, omnipotent, and all good sounds to me much more like a religion, than a science. And it seems to me that although I grant to the practitioners or would-be practitioners of METI their religious freedom, I don't grant to them their right to impose their religion on the rest of us.
Yeah, it's a problem, and I think if you ask most people, they're going to say, "Don't send a message until we know exactly what this is." But you're right. A lot of people, for some reason, make the assumption that an alien civilization is going to be altruistic and in some way more socially advanced than the humans. But there's no guarantee of that. It may be worse. They could be nightmares for all we know. And maybe the first signal that we get is a threat or something like that,
Yeah.
where they're just very, very predatory. Maybe they send out a T-Rexes or something, the alien version of a T-Rex, and they're just inherently aggressive.
Well, the METI people or proponents will come up with an elaborate reason as to why it is that ET must be benign and altruistic. Why, after all, they've lived as long as they have. The only way they could have done that is to have conquered all their aggressive or dealt with all of their aggressive tendencies, and only the nice cooperative civilizations would actually not self-destruct, and yada yada yada. But what about us? I mean, we're nice to our neighbors. We're not so nice to people that aren't not considered our neighbors, the other, so-called other. What about dolphins? Dolphins and we get along just fine. We're both intelligent species. And we're both benign to one another. But if you ask any squid, another intelligent species, they're going to tell you that both dolphins and humans are heartless, merciless killers. Okay, so it's not at all sure that even if ET is benign to its own kind or benign to others, that they won't treat us pretty shabbily. We just don't know. We have no idea.
And here I'm going to switch gears. Now, John, you also have another interest area, another career, and that is making movies, these Zorro movies, and you've made them for quite some time. What's that like, and how did you get involved with the Zorro universe?
Okay, well, I live in the San Francisco Bay Area. I originally came here in order to do a doctorate at UCSF at the medical school, and I was a starving student and somehow blundered into the Zorro situation, and as a way to work my way through school, I acquired the rights to Zorro. Partly I inherited the rights, and partly I acquired rights from Walt Disney and the estate of the creator, and ended up with the rights in my own hands. But those rights were thought to be fairly useless. And what I needed to do was develop concepts for motion pictures and television and so forth. And I started doing that and hit the streets and knocked on doors in Hollywood and that sort of thing, and eventually started selling ideas and segueing out of academia and into a full-time career as a minor movie mogul. So to date, I've made 4 feature film versions of Zorro, 14 different television versions, over 600 episodes, and maybe about 75 or more different stage adaptations, and then books, toys, games, clothes, commercials, and so forth. So while I was doing that, and my interest, however, in science segued from my original field was psychophysiology and chronobiology to astronomy, and that's how I developed an interest in SETI, and that's how it is today. My life is sort of split in half as I said, a minor movie mogul on the one hand, and as an aspiring SETI theorist on the other.
What is the future of Zorro? Is there going to be more content?
Yeah, I've got actually 2 television series in production at the moment, one in which premieres on Amazon on January 19th, and the other which will premiere on Paramount Plus towards Christmas of next year. Then I have 2 more TV series in development, one at Disney Plus and another at CBS Network. And then 4 feature film versions that I'm working on with Sony Pictures. One, a version that's based upon Tarantino's and my graphic novel called Django Zorro, which is a mashup of his Django and my Zorro. He wrote it. And then when he finished writing it, I took it over to the studio and they went wild about it and said, hey, let's make this into a movie. So we're working on that version and an animated version and a hybrid live action animated version. And then finally a prequel based upon, the story about how Zorro became Zorro, the childhood and so forth of Zorro. Anyway, so that's kind of slice of life for me in Zorro land.
Now, Zorro has a long history. That was started, 1919, something like that is the original story, right?
That's correct. It was originally created by Johnston McCulley, who wrote 65 Zorro short stories and novels starting in 1919 until his death in 1958.
It's an interesting world. It was always sort of an unusual, not quite a superhero, but a proto-superheroes, sort of the prototype of like the Marvel universe and things that came much later.
Correct. Zorro, we don't think of Zorro as a superhero because he has no superpowers. He deals with his villains by wit and humor and athleticism, and he's just very sexy, and but he was a prototype. Bob Kane, who created Batman, has admitted in his biography and many other places that he basically based his character on Zorro. He just took the fox, the nocturnal fox, and made him into a nocturnal bat. Took the black horse and turned it into a black Batmobile. Both of them were effete gentlemen by day and rich gentlemen by day, and by evening in a cave, putting on the dark mask and so forth. So yes, I mean, Zorro definitely foreshadowed the universe of superheroes, but we think of him as sort of an everyman. Anybody could be Zorro. You don't need to be bit by a radioactive spider or anything. Just go out and do good things.
All right, John, thank you for joining us today. It was a fascinating conversation, and the one thing I hope I see is an alien signal of some sort of sign that we are not alone.
Well, yeah, all of us in the SETI business hope that we did find a signal in our lifetimes. But, we should, all of us in this business, realize that this is the work of generations. It may not be us, it may be many generations hence that make the first detection of SETI, and that we're just stepping stones along that way. I see SETI scientists who, are almost aggrieved that they are not the ones to make the detection. Others, like Frank Drake, went out with a smile on his face and was happy. But some SETI scientists can really become pathetic figures in their hopes and dreams for being the one to detect ET, and it doesn't happen.
Well, all you do is make contributions. That's science. It's a corpus of knowledge, and you just look and you pass on what you've thought of and what you learned. So just the idea of that we know how to do SETI is the contribution of past scientists. So
I so agree.
Yeah,
I so agree. definitely.
All right, thank you, John, and I look forward to seeing the next movie.
Well, thanks, John. It's a pleasure to be here.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.